Hello, you absolute legends. Consider adding a solution intravenously through the veins into your circulatory system. We want those solutions, we want this aqueous solution to be very similar to your blood, so that way that it mixes evenly and uniformly, like even just making sure it's the same temperature. Now we want to make sure that the solution of glucose is the same pressure or equal to your blood. The osmotic pressure of human blood is 7.6 atm at 37 degrees centigrade. What mass of glucose is required to make 1 liter of aqueous solution for intravenous feeding if the solution must have the same osmotic pressure as your blood at body temperature? Assume ideal solution behavior right here. Let me finish up my shopping list based on reading that question there. They said the pressure of blood, osmotic pressure of blood is 7.6 atm at 37 degrees Celsius. What mass of glucose, grams of glucose, we'll just leave this over here for board space, but in the shopping list, is required to make 1 liter of aqueous solution for intravenous feeding at 37 degrees Celsius. So we want our final answer in grams. And we know our pressure here. We know the degrees right here. How are we going to get our final answer in grams? We're not given anything with grams so far, but we are told that we're talking about glucose. In glucose, we have molecular formula. We can look up the molecular weight of glucose. Let's start with that. Glucose is C6H12O6. It has a molecular weight of give or take 180 grams per mole. So boom. Now I have grams on top, moles in the bottom. Okay. Now this is grams of glucose. Now my goal here is, this is the smart start. I want my final answer in grams of glucose, and this is a number about glucose, specifically about glucose, the molecular weight, and it happens to contain grams. That is why I'm choosing to put it in this number, in this manner. So now my only goal is to try to cancel out moles here at some point. I look at my shopping list. I don't have anything in moles here, but osmotic pressure, gases, the behavior, the atomic vision, movement and motion of solutions in liquid phase is very similar to the atomic vision, motion and movement of gases. So therefore we can use some properties that describe gases and also use them for solutions. The ideal gas constant contains moles, so we will plug in the ideal gas constant to make moles cancel. Ideal gas constant is an ugly big thing. It's got 4 units in there, and I'm writing it in here flipped already because I know that I want top to cancel out bottom. All right, well, I canceled out this guy, but I made my problem worse, but I just got to keep hacking at it. Can I cancel? Oh, great, I got a liters. Great, 1 down. I have the temperature, and there's my pressure. Okay. Let me do my pressure first. That way, there's no conversions. 7.6 atm is the pressure, the osmotic pressure of blood. That's much higher than atmospheric pressure, 1 atm. And if you think about the possibility of your blood boiling away, you would very much appreciate of how high that osmotic pressure is. Temperature at 273, what is that, 310, I think? 310 Kelvin. I might be wrong. I'm just going to go with that because we're almost done the problem. But I placed these numbers from my shopping list in locations to make units cancel, so that way the only thing left is grams. And from here, I could calculate how many grams of glucose I would add to this solution, so that way it is healthy to go intravenously into your blood. I hope this helps. Thank you.